Imagine walking into a pharmacology exam and seeing a question about cholinergic drugs. Most students panic because they try to memorize hundreds of facts, but cholinergic pharmacology is actually one simple story centered around a single molecule, acetylcholine. Acetylcholine is the main neurotransmitter of the parasympathetic nervous system, also known as the rest and digest system. Whenever acetylcholine is released, the body shifts into a relaxed state. The heart slows down, digestion increases, saliva production increases, the bladder contracts, and the pupils become smaller. Think of someone relaxing after a big meal. They are not running from danger. They are resting, digesting food, and conserving energy. That is exactly what acetylcholine does. Acetylcholine works by binding to receptors. Think of receptors as locks and acetylcholine as the key. There are only two major receptor families you need to know: muscarinic receptors and nicotinic receptors. Muscarinic receptors are found mainly in organs such as the heart, eyes, lungs, gastrointestinal tract, bladder, and glands. The three most important muscarinic receptors are M1, M2, and M3. M1 is found mainly in the brain and stomach. Think M1 equals mind. M2 is found mainly in the heart. Its job is to slow the heart rate. Think M2 equals heart. M3 is the most important receptor for exams. It is found in glands and smooth muscles. When activated, it increases saliva, tears, stomach secretions, bowel activity, bladder contraction, bronchoconstriction, and pupil constriction. Think of M3 as the wet and squeeze receptor because it increases secretions and contracts smooth muscle. Nicotinic receptors are easier. NN receptors are found in autonomic ganglia. Think NN equals nervous system. NM receptors are found at the neuromuscular junction and help skeletal muscles contract. Think NM equals muscle. Now, let's discuss cholinergic drugs. These are drugs that increase the effects of acetylcholine. The first group is called direct-acting agonists. These drugs directly stimulate cholinergic receptors. One important example is Bethanechol. Bethanechol stimulates muscarinic receptors in the bladder and helps patients urinate. Whenever you hear Bethanechol, think bladder. Another important drug is Pilocarpine. Pilocarpine increases saliva production and constricts the pupil. It is commonly used for glaucoma and dry mouth. Think pilocarpine equals saliva and glaucoma. The second group is called indirect acting agonists. These drugs do not stimulate receptors directly. Instead, they inhibit acetylcholinesterase, the enzyme that breaks down acetylcholine. When acetylcholinesterase is blocked, acetylcholine accumulates. More acetylcholine means stronger cholinergic effects. Examples include Neostigmine, Pyridostigmine, and Donepezil. Neostigmine and Pyridostigmine are used to treat myasthenia gravis, a disease characterized by muscle weakness. By increasing acetylcholine levels, these drugs improve muscle strength. Donepezil is used in Alzheimer's disease because it increases acetylcholine levels in the brain and may improve memory. Now, let's discuss what happens when there is too much acetylcholine. This is called cholinergic toxicity. A common cause is organophosphate poisoning, often from pesticides. Organophosphates block acetylcholinesterase, causing acetylcholine to accumulate throughout the body. The classic symptoms can be remembered using the mnemonic SLUDGE. S for salivation, L for lacrimation, U for urination, D for defecation, G for gastrointestinal cramps, E for emesis. Many students also add M for meiosis. Patients may have excessive saliva, tears, diarrhea, vomiting, sweating, bronchospasm, and a slow heart rate. A simple way to remember cholinergic toxicity is this: everything becomes wet and slow. Treatment involves two important drugs. The first is atropine. Atropine blocks muscarinic receptors and reverses many dangerous symptoms such as excessive secretions, bronchospasm, and bradycardia. The second is pralidoxime. Pralidoxime reactivates acetylcholinesterase and helps correct the underlying problem. Let's finish with a rapid review. Acetylcholine is the neurotransmitter of the parasympathetic nervous system. M1 equals mind, M2 equals heart, M3 equals wet and squeeze, NN equals nervous system, NM equals muscle, Bethanechol equals bladder, Pilocarpine equals saliva and glaucoma, Neostigmine equals myasthenia gravis, Donepezil equals Alzheimer's disease. Too much acetylcholine causes SLUDGE symptoms. Organophosphate poisoning is treated with atropine and pralidoxime. And remember the golden rule. Acetylcholine makes the body wet, slow, and ready to digest. If a drug increases acetylcholine, expect parasympathetic effects. If a drug blocks acetylcholine, expect the opposite. Master that idea, and cholinergic pharmacology becomes one of the easiest topics in pharmacology. If you find this video useful, please hit that subscribe button.